All right, hello everyone, and welcome to lesson 1.2. We're going to be talking about representing a categorical variable with tables. And in fact, we're actually going to be pushing into a few ideas that are also in Unit 2 on representing more than one categorical variable with tables, kind of teasing some of those ideas. You should have your notebook set up, and we're going to be walking through this introductory lesson. There'll be places along the way where the video will stop. You'll have something you need to do, and you'll keep going. But as we work through this video, pretend like you're in class. Take notes where you see the note symbol, and make note of the things that I am asking you to draw your attention to as well. Okay? Don't forget at the end of this video that you'll need to complete the rest of the Nearpod. There'll be a little check-in quiz and a survey I want you to fill out giving me some feedback. So let's go ahead and begin talking about representing a categorical variable with tables. Just as a reminder, we are here Monday in our asynchronous lesson for lesson 1.2. That'll lead into representing categorical variables with graphs on Wednesday. So this whole unit really is talking about variables, how we represent them, why we care about them, and some of the basic ways to describe the data collected on specific variables. We're continuing to look at these types of variables over the next week and a half or so. This being the very beginning of statistics, we do have a lot of vocabulary. So let's continue building out our vocabulary. I do encourage you as you walk through this lesson, as you go through this unit, to really keep close tabs on the vocabulary. And in fact, start marking them somehow with a little star or underlining them, color coding them, because we will be spending a lot of time making sure we understand that vocabulary. And for today, there's a few things I want you to be aware of. First is this phrase frequency table. A frequency table shows the number of individuals having each value of some specific categorical variable, as we'll see on the next page. A relative frequency table shows the proportion or percent of individuals that have each value of some categorical variable. When we are talking about percentage, relative frequencies, and rates, we understand that they are really actually all just talking about proportions. They're really all talking about the same thing. A percentage is really a proportion of a population or a proportion of a sample that has a specific value. That's the same thing as relative frequency, which is the same thing as the rate at which that categorical category is met in the table. All right. Let's take a look at a quick example. So here, let's say we've collected some data on preferred methods of communication. And we surveyed 10 students, right? I could present that information in a tally. Here we go. Cell phone is 2, Facebook is 1, in-person is 3, text message is 4. But I could put that in what we call a frequency table. This frequency table is measuring the categorical variable preferred method. Our categorical variable here is preferred method. This is our variable. All right. I should have said, for this kind of information for today, I do actually want you to write down the different tables because I'm going to be talking about them for a little bit. So I would like you to take the time to copy down the tables, at least in sort of minimal mode here. Okay. The frequency table is right here, and you can tell that we're just measuring the frequency or the count, 2, 1, 3, 4 of each preferred method of this categorical variable. All right. But I could also create from that same information what's called a relative frequency table. And to do that, all we do is we take the frequency of each category and divide it by the total, which I could have put down here as 10. So cell phone, its relative frequency is 2/10. We can also say 1/5, which is 0.20 or 20%. That is the relative frequency at which responses for cell phone happened. Same thing, relative frequency for Facebook is 10%. The in-person relative frequency was 30% or 3/10. Again, percentages, proportions, rates, these are all really referring to the same thing. Text message, 40% frequency there of respondees. Now, it is important to also remember that technically tables like this are summarizing data. Oftentimes you'll hear people refer to these tables as, well, when you look at the data, this is technically not data. The data is that raw stuff you collect from the surveys and the people. These are summarizations, displays of that data. All right. Technically, we could also make these kinds of tables for quantitative variables if we wanted to as well. However, if you think about it, you probably don't want to tend to do this because quantitative variables can have many categories. For example, if I surveyed people to ask them, how old are you? Well, you might end up, if I survey 100 people, with 100 different ages. And so each category, you have 100 different categories in a table. That's not going to be super useful, right? So typically, we don't display quantitative variables this way in tables that look like this. Again, I do want you copying down these tables just so you have something to label and look at as examples, even if you're doing a quick version of it with abbreviations and things like that. Fortunately, the table's on the next page too. Okay. As a reminder, it is crucial, fundamental to our thinking that when we're talking about relative frequencies, that is the same thing as a percentage or a rate or a proportion. They really are the same thing. Sometimes when people are displaying data, they will summarize that data as percentages. That's actually fairly common to summarize data in sort of percentage format. Those are still sort of relative frequencies, okay? So just because we don't see them as decimals, which is oftentimes how they're introduced in textbooks, that doesn't mean it's not a relative frequency. Any of these count as relative frequencies. And as you probably have seen in newspapers and online, percentages are actually the probably most common way that happens because for some reason people get uncomfortable. Lay people get uncomfortable when you describe things as decimals. So be on the lookout for the differences there. All right, a little more vocabulary here. So those frequency tables we saw in the last slide are really only measuring one categorical variable. In that case, it was what is your preferred method of communication, right? But sometimes it's actually really useful to have what we call a two-way table. A two-way table of counts, a two-way table is a table of counts that summarizes data on the relationship between two categorical variables for some group of individuals. Usually one is kept in sort of like the vertical column, vertical axis, and one is kept in the horizontal axis if you're looking at a table, so that rows and columns represent slightly different things, as we'll see. Two-way tables can either show frequencies, and you'll see I've started to use this abbreviation, this FREC for frequencies, or RelFREC for relative frequencies. You'll see me do that. It's just a way to speed up the typing, and I encourage you to do the same thing as you're writing, just your own work if you're not doing something official. So you can do tables, two-way tables that either show frequencies or relative frequencies. Both are totally fine. Turns out that relative frequencies are actually nice, and a lot of people prefer to report relative frequencies because people are actually bad at comparing things. Maybe that surprises you, maybe it doesn't. But if you had a table that is all done in frequencies and maybe you surveyed 1,372 people, and you start doing numbers like 513 people said this, 417 people said this, most lay people have a hard time understanding whether or not that is a significant difference between those kinds of numbers. So we often report things in relative frequencies because if someone says 35% is this, 25% is that, people have a better sense of what that means if you're doing it relatively out of that 100, which is what a percent is. All right, another example and another table to write down, but this table we'll actually use multiple times. So label this one and we will actually return to this. So maybe leave some space around it so you can do some work and return to it later on. Let's say we have this two-way frequency table, or sorry, two-way table. This is a, two-way frequency table. That's just measuring the counts of student athletic participation by class. So I surveyed people, let's say, and found out, are you in Markwalter's class or are you in Dr. Zaren's class? And then of these four sports, which of these do you play? Soccer, ultimate, curling, fencing. Those four sports are what people were surveyed on. All right. And let's say, just for the sake of cleaning things up, that all students played one of these four sports. Let's say, I don't know, we went to some strange school where you're required to play either soccer, ultimate, curling, or fencing. All right. We can use tables like this after we've collected information to, make some justifications. For example, we can use this table to pretty quickly justify that among students in Markwalter's, forgot the S there, Markwalter's and Dr. Zaren's classes, Fencing is the least played sport among those included in the survey. It has the lowest count, right? We can justify it as the least played sport because it has the lowest count. In fact, we could go even farther and say, well, if you dig into the data here, technically, it not only has the lowest count overall, 7 compared to the other sports, but it also has the lowest individual counts within each class. 5 compared to 8, 7, and 10, and 2 compared to 13, 4, and 11. So we can make justifications using numbers. But the important thing here as we dig into this year is that you always need to support your conclusion with specifics. So I simply said here it has the lowest count, but if we wanted to, we could have said its count 7 is lower than the counts of all the other sports, or something similar. All right. Again, we will return to this table, so at times if you need to pause this video to take notes and write things down, feel free to do so. Let's rock and roll. Okay. Another table that we'll return to over the course of this little video. So this is I believe the last one I have you write down. So this will be another table I want you to write down, but we'll return to it a couple times in a row. Let's do something slightly different. Let's say I surveyed 200 students about their hair and their eye color. Look over here. This chart looks a little different. Even without labeling it correctly here, and notice I haven't put a label here, pause and think to yourself, does this look like this is going to be a two-way? Again, we're measuring two categorical variables here, hair color and eye color. Those are two categorical variables, just like class and sport played were the categorical variables above. In this two-way table, is it a two-way frequency table or is it a two-way relative frequency table? Just think that to yourself for a second. Is this a two-way frequency table or a two-way relative frequency table, you think? All right. Well, if you thought to yourself, well, I doubt it's a frequency table because there's no way that 0.35 persons responded, you are correct. This is not a frequency table. This is a relative frequency table. We know that because even without me labeling things properly, and if you make a table, you should always label them properly, but here I withheld those. This is a relative frequency table because it looks like our responses are now simplified into decimals, which we could convert to percents to do some come up with some understanding of what is the proportion or fraction of people who responded each way to each variable. This is a relative frequency table. All right. So let's see what we can do with this. How many of the surveyed students have blue eyes and brown hair? All right. The nice thing about two-way frequency tables, we can find kind of the intersection of those things. We want people with blue eyes and brown hair. It looks like they are right here. That is the frequency of people with blue eyes and brown hair. So that is 0.125. But that is the frequency, right? But I want to know how many of the surveyed students. I need a number of students. So if this is the frequency, how do I figure out the actual number of students? Well, I have to look back up to the total number surveyed. Total number surveyed was 200. So if I multiply my frequency, which was 0.125, which is my proportion of people who fell into the brown hair, blue eye category, and multiply it by 200, we can do that real quick. 0.125 times 200 will give us 25 people. So it looks like 25 students of those surveyed fall into the category of brown-haired and blue-eyed. Let's see if we can do this. How many of the surveyed students have just brown eyes? Well, if we go to brown eyes, we don't care, brown eyes. If we go to brown eye category, that's this one up here, right? We could do that. Let's do that in a different color, maybe red. Brown eyes is up here. We actually don't care about the hair color. So how many people, what is the frequency, relative frequency with which people have brown eyes? Well, it is right here. It is the total of this brown-eyed category. 0.650 is the relative frequency at which respondents have brown eyes. Now, if I want the actual number of respondents, I need to multiply that by the total number of respondents overall. So there were 0.65 or 65% of respondents had brown eyes. Out of a total of 200 respondents, multiply the decimal times the 200, and we'll find that 130 students have brown eyes of those, well, students of those who responded to the survey. So relative frequency tables are nice because if we know the total, the relative frequencies are pretty easy to compare. We can say, oh wow, like the largest percentage of people clearly had brown eyes compared to blue or other. We can do some quick comparisons that way, and we can get some hard numbers if we know the number of people surveyed. All right, I'm gonna have you practice here in a second. Using the same table, we have 200 people, students surveyed. I want you to think about the question, how many of the surveyed students have red hair? Write that question down and work it out. How many of the surveyed students have red hair? Write that question down and work it out, and then answer the question that pops up on the video. All right. Let's keep the pen red since we're talking about red hair here. Let's see, red hair. We're looking at just this row then over here. What is the total number of respondents, relative frequency, sorry, not number. What is the total frequency with which respondents had red hair? It looks like it was 0.05. So to get the total number of students, 0.05 students times the, 0.05 was the frequency, times the total number of students, should tell us the actual number of students who have red hair. 0.05, which is 5%, times 200. It looks like there were 10 students who had red hair. All right. There we go. All right, a little more vocabulary here. So we've been looking at tables, frequency tables and relative frequency tables. We've also seen now two-way frequency tables that measure two categorical variables. With two-way relative frequency tables and two-way frequency tables, there's a few other key ideas. We're going to talk about two of them today and then dig into more of them in Unit 2. First, let's talk about marginal relative frequency. Marginal relative frequency is the percent or proportion of individuals that have a specific value for one categorical variable. So in this case, our marginal relative frequencies are going to be right here. Actually, I should back that up. It's not all the way over there. Our marginal relative frequencies are right there, these guys. And you know what? Change of plans. Let's do it like this. We'll just box the whole set of this. There's the marginal relative frequencies. And here are the marginal relative frequencies. All right? I want to call them marginal relative frequencies to abbreviate that. All right? What easy way to remember this, marginal relative frequencies live on the margins of the table. You know, margins on a piece of paper are the things on the edges. So the things that live on the edges, that are the sort of totals, if you will, percents or proportions, and since we're talking about relative frequencies, we are talking about the percent or proportion that have one categorical variable. They're kind of like the percent totals over here, or the percent totals down there. Those are our marginal relative frequencies. Those things that live in the middle of the table are what we call joint relative frequencies. A joint relative frequency is the percent or proportion, sorry about that, or proportion. That should be an R, or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. So the joint relative frequency would be all of this stuff in here. We call it joint because it is the combination of two categorical variables. It's the percent or proportion that essentially has both specific values of a categorical variable. All right, those are our joint relative frequencies. You can go ahead and label those on the table you should have already copied down. That was a relative frequency table. All right, so let's take a look at some examples here using that vocabulary we just learned. Let's calculate the marginal relative frequency for students who play soccer. And we're going back to that student athletic participation by class table. So you can go back to where you had in your notes up there, and we're going to do some labeling here. So the marginal relative frequency, that's the stuff on the edges, right? It has to do with comparing to the total. The marginal relative frequency for students who play soccer. Well, how many students play soccer? It's 21, right? So the marginal relative frequency is going to be 21 out of the total, which is 60. 21 out of 60, which will give us, if you want it as like a decimal here, 0.35, or I guess we could say 35%. That is the marginal relative frequency for students who play soccer. All right. Notice if we total that up for each column, we would then be able to sum it up to 100, because over here we'd have like a 60 out of 60 situation. Now let's calculate the joint relative frequency for students who play Ultimate. Oh, that should just say and are in Markwalter's class. All right. So the joint stuff is on the inside. So we want students who play Ultimate and are in Markwalter's class. So the students who are Ultimate players and in Markwalter's class, looks like it's 4. So if we do 4 out of the total, which is 60 students, that'll give us 4/60ths, or if we want that as a decimal, that'd be 4 out of 60, or 0.67. I did not even put that decimal place in the right spot. 0.067, my bad, would be the joint relative frequency. The joint is the combination, the joining of Ultimate and Markwalter's class, which is 4 out of the total, which is 60 students. There's the joint relative frequency. All right. What I'd like you to do now is, using that same table, I want you to practice this. 2 questions. 1, calculate the marginal relative frequency for students who are curlers from the table, and calculate the joint relative frequency for students who are in Dr. Zarin's class and fence. All right? Go ahead and do that and answer the 2 questions that pop up. All right, so let's take a look. If we want to calculate the marginal relative frequency for students who are curlers, students who are curlers is right here. There are 21, and it's 21 out of 60, which actually happens to be the same proportion as what we saw earlier for our soccer players, right? So that is 0.35, or 35%, is our marginal relative frequency for our curlers. Now the joint relative frequency for students who are in Dr. Zarin's class and fence, that'd be these guys or girls right there, those people I should say, let's not be specific. 5 out of 60 would be our joint relative frequency. Our joint relative frequency as a decimal will be 0.083. That's an 8 there. It's a weird looking 8, but that is an 8 nonetheless. 8.3. All right. So there we go. We've calculated the marginal relative frequency and the joint relative frequency for our fencers in Dr. Zarin's class. To close out with, I want you to take a look at this. Here's a table at the right that was collected through some data gathering that the Pew Research Center has done. You'll see I'll come back to those people a lot because they run good surveys and have really interesting articles about the data they collect. It's not a true two-way frequency table because the things don't actually all sum up to 100 because we're looking at different countries. But it is still an enlightening table to look at that we can work on practicing making conclusions from. I want you to look at this table about the percent of Hindus who say science has ever disagreed with the teachings of their religion, and the responses from 4 different countries. I want you to look at that data and digest it for a little bit. Really look at the numbers. What would you say is the main conclusion that you would gather from this table regarding Hindus' feelings about science and their religion? Then I want you to support your conclusion with information in the table. I actually want you to cite a number or 2 or more here in making your conclusion about what would you say your main takeaway from this is about Hindus' feelings regarding science and their religion. You can only make one conclusion here. Imagine you're the researcher, you're making one conclusion here. Go ahead and answer the question that pops up. All right. Well, thank you for listening today. Please make sure you continue the rest of your pod, answer the check-in questions and the survey that follows, and I look forward to seeing you next live class. Bye.